What is the reason behind the brilliance of diamonds? What is the reason behind the formation of mirages? What is the basic principle behind working of optical fiber? For these three questions, only one answer, that is total internal reflection. Total internal reflection. By doing an activity, we are going to know about critical angle and total internal reflection. So my dear children, please watch. For this activity, we need a plank covered by white chart, semicircular glass disc, circular protractor, and a laser light. Take a wooden plank which is covered with white chart. Draw two perpendicular lines passing through the middle of the paper. Mark horizontal line as mm while vertical line as nn. Draw a circle and mark angles from 0 degrees to 90 degrees in 4 quarters of the circle by using a circular protractor. Now place a semicircular glass disc so that its diameter coincides with the line mm. Here glass disc is denser medium and air is rarer medium. The line mm is interface of the two media. The line nn is normal. Then we send a laser light through glass disc. It bends away from the normal. Why? Because it travels denser medium to rarer medium, and at the same time some part of the light is reflected into the glass disc. Here there are three angles, that is angle of incidence, angle of refraction, and angle of reflection. Let us observe carefully. When we increase angle of incidence, the angle of refraction also increases respectively. But at certain angle of incidence, the refracted ray, observe the refracted ray. The refracted ray grazes the interface of glass and air. After that, refraction does not take place. Totally the light reflected into the denser medium. This phenomenon is called total internal reflection. We can understand about critical angle and total internal reflection by using this activity. Here, my dear children, observe the activity carefully. When light ray passes through the normal, does not deviate. When light passes through 10 degrees, it refracts at 15 degrees, and some part of light reflects at 10 degrees. When light passes through 20 degrees, it refracts at 30 degrees, and some part of the light reflects at 20 degrees. When light passes through 30 degrees, it refracts at 50 degrees, and some part of the light reflects at 30 degrees. When light passes through 40 degrees, it refracts at 80 degrees, and some part of light reflects at 40 degrees. Observe carefully, my dear children. When light passes through 42 degrees, refracted ray grazes the interface, and some part of light reflected into the glass slab. So here 42 degrees is the critical angle of glass slab. So critical angle means the angle of incidence at which the light ray travelling from denser to rarer grazes the interface. That is critical angle for denser medium. When the angle of incidence is greater than critical angle, so refraction does not take place. The total light ray is reflected into denser medium. This phenomenon is called total internal reflection. Now we are going to understand the reason for brilliance of diamond. The critical angle of diamond is very low, that is 24.4 degrees. So if a light ray enters a diamond, it is very likely to undergo total internal reflection, which makes the diamond shine. Do you know about mirages? Mirage is an optical illusion where it appears that water has collected on the road at a distant place, but when we get there, we do not find any water. The formation of mirage is the best example for total internal reflection. During a hot summer day, air just above the road surface is very hot and the air at higher altitudes is cool. Here, hot air acts as rarer medium and cool air acts as denser medium. Right. When the light from a tall object such as tree or from the sky passes from cool air to hot air, takes a curved path because of total internal reflection. This appears to the observer as if the ray is reflected from the ground. Hence we feel the illusion of water being present on road, which is the virtual image of the sky and an inverted image of tree on the road. An optical fiber is very thin fiber made of glass or plastic. There is bending, but light is transmitted along the fibers from one end to another end because of total internal reflection of light. My dear children, please watch the activity. Total internal reflection is the basic principle behind working of optical fiber. The angle of incidence is greater than the critical angle and hence total internal reflection takes place. The light is thus transmitted along the fiber. By using optical fibers, endoscopic light is prepared. The doctor inserts an optical fiber pipe into the stomach through the mouth. Light is sent down through one set of fibers in the pipe. This illuminates the inside of the stomach. The light from the inside travels back through another set of fibers in the pipe and the viewer gets the image at the outer end.